Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder if the way you look at things actually affects how smart you are at certain tasks, especially math? Well, this new study might have a clue. Today we're diving into some fascinating research about how our eyes might play a surprising role in becoming a math whiz, specifically in algebra. You know, that abstract stuff with letters and numbers that can feel a bit like a foreign language sometimes. Scientists are asking, does becoming good at algebra mean you stop needing to look at the written equations so much, or does it actually mean you get better at using your eyes to help you solve those problems? So algebra is all about abstract thinking, right? We're supposed to be manipulating symbols and understanding underlying structures. But here's the kicker, we do all this math on paper, on screens in places we can see. And that brings up a big question, does the way we physically interact with these equations, like how we move our eyes, actually change how well we do in algebra? There are two main ideas, or accounts, about how this might work. The first is called the visuospatial scaffold account. Think of a scaffold on a building. It is there to help you build. But once the building is up, you don't need it anymore. This idea suggests that when you are new to algebra, you rely on the visual layout of the equation, like where the numbers and symbols are placed, to help you figure things out. But as you get better, you internalize the rules and don't need that visual scaffolding as much. Experts in this view would just quickly grasp the abstract structure in their minds without needing to strategically scan the equation. It is like learning to ride a bike at first. You need training wheels, but eventually you just ride. The second idea is the visuospatial skill account. This one says that being an expert means you've learned to use your eyes more skillfully to interact with those external equations. Instead of discarding the visual cues, experts actually learn to exploit them even more. They might move their eyes in very specific ways to quickly find the most important parts of an equation to help them solve it. It's like a master artist who doesn't just see a canvas, but sees how to use every brushstroke and color to create a masterpiece. Experts in this view use their eyes as a tool, coupling their gaze with the visual layout to enhance their thinking. To figure out which of these ideas is right, the researchers designed a really cool experiment. They got 60 college students and, importantly, they measured how good each student was at algebra. Before the main experiment, they did this with a quick test about something called operator precedence, which is basically knowing the order of operations like PEMDAS or BODMAS. Then came the main event. The participants sat in front of a computer and an eye tracker watched exactly where they looked. They were shown algebraic equations and had to do two types of tasks. In one task, the algebraic equivalence task, they had to decide if the equation was true. For example, is A times B plus C times D the same as C times D plus A times D plus A times B? This requires understanding the structure of the equation. But here is the clever part. They also had them do a letter search task with the exact same equations. In this task, they just had to see if a specific letter was in the same spot on both sides of the equal sign. This task doesn't really need complex algebraic thinking. It is more about visual search. By comparing how people looked at the equations in these two different tasks, the researchers could see if their eye movements were driven by the abstract math problem or just the visual layout. They also tweaked the equations themselves, sometimes putting multiplication in the middle and sometimes addition to see if people paid more attention to the more important operators, the ones that get done first. So what did they find? First off, the students who were already good at the pre-test, the algebra knowers, actually performed much better on the main algebraic equivalence task. This makes sense. If you are better at the basics, you are likely better at applying them. But the really exciting part was about their eyes. Remember those two accounts. The scaffold account predicted experts would look less strategically, while the skill account predicted they'd look more strategically. And guess what? The results totally supported the visuospatial skill account. The students who were better at algebra, the algebra knowers, actually showed a bigger precedence advantage. This means they spend proportionally more time looking at the multiplication operators, which have higher precedence compared to the addition operators. They were strategically directing their gaze to the parts of the equation that mattered most for solving the problem. Even more importantly, this strategic looking only happened when they were actually doing the algebraic equivalence task. When they did the letter search task with the same equations, the algebra knowers didn't show that same precedence advantage anymore. This means their eye movements weren't just randomly drawn to multiplication signs. They were actively using their gaze as a tool to help them solve the algebra problem. They were coupling their vision to the structure of the equation when it mattered for the task. The algebra non-knowers, on the other hand, didn't show this strategic looking in either task. But does this strategic looking actually help them do better? The researchers did a special analysis to find out. They found that the more precedence advantage a participant had, meaning the more they strategically focused on the higher precedence operators, the better they performed on the algebraic equivalence task. This strategic eye movement actually explained why the experts were better at solving the problems. It wasn't just that they were smarter, it was that they knew how to look at the problem to help them think. This is huge. It suggests that algebraic expertise isn't just about abstract thought happening purely in your head. It is also about developing a kind of perceptual skill learning to use your eyes to effectively interact with the external representations of math. So, what does this all mean? It strongly supports the idea that becoming an algebra expert involves learning to use your eyes more strategically to exploit the visual structure of equations. It's like mathematicians are so good because they've learned to look at math in a very particular, effective way. This research really highlights how our physical interactions with math, like looking at equations, are not just passive activities but active parts of the thinking process. Math is super abstract, but we do it in a very concrete way, using our hands to write and our eyes to scan. And it seems that how we use our eyes can be a really important part of becoming good at it. This also has some cool implications for how we teach math. If learning where to look is part of algebraic expertise, then maybe teaching students how to visually scan equations in a strategic way could be a really effective teaching method. Imagine a lesson that focuses not just on the rules of algebra, but on how to visually approach the equations to best understand structure. So, to sum it all up, this study found that math experts don't just think differently, they also look differently at math problems. Their strategic eye movements are a key part of their expertise, helping them perform better. It's a reminder that even the most abstract thinking can be deeply connected to our perception and our physical interaction with the world. Now, what do I think about this? I find it absolutely fascinating. It flips the script a bit, showing that sometimes the path to abstract understanding involves honing our concrete perceptual skills. The visuospatial skill account really resonated with me because it emphasizes that expertise isn't always about internalizing and discarding external aids, but sometimes about becoming a more skillful user of those aids. One potential limitation to consider is that this study was with college students. Would the same findings hold true for younger learners or mathematicians with decades of experience? And while the tasks were designed to differentiate between algebraic reasoning and visual search, it is always complex to perfectly disentangle cognitive processes, but the implications are really exciting for education. It suggests we might need to be more mindful of teaching perceptual skills alongside conceptual ones in math. For our understanding of abstract thought in general, it reinforces the idea that cognition isn't just happening in the head, but is deeply intertwined with our bodies and the environment. It makes you wonder, what other abstract skills might be improved by training our perceptual systems? This research opens up a lot of doors for future studies. I'd love to see research that directly trains students on where to look in equations and then measures their improvement. Also, exploring this in other areas of math, like calculus or geometry, would be super interesting. What do you all think? Have you ever noticed yourself looking at math problems in a specific way? Let me know in the comments below, and if you found this breakdown helpful, please give this video a thumbs up and subscribe to RUBIN'S Mind Lab for more explorations into the fascinating world of psychology. Thanks for watching, and I'll see you in the next one.